Well, we should be live. It certainly looks like we are. And thanks for tuning in, YouTube crew. I'm here standing in front of the Chrome Hat in the Smasho Studio 2.0, where we're running Ubuntu. Yeah, a Linux OS. Just got back from trail time. And just a quick reminder that there is no substitute for trail time, folks. There's no substitute. So the stuff that you'll experience and the nature experiences you'll get and the feeling of awesomeness that you'll receive on the trail uh, is something that you're not going to get elsewhere. And here's a little consumer tip. All right, now we could offer you a link to this and so on. I don't think this one's in the Amazon shop, but one of the most important investments that I've made as an athlete in the past 2 years has only cost $30. So check this out. I bought these cheap duck boots. They are not high end by any stretch. I think they cost $30 on Amazon. They're side zip. They just slip right on. I don't even have to unzip the sides. They have like a felt liner, kind of like old school Sorel boots, if any of you have ever had any of those. I used to wear Sorels back in the 80s and 90s. You know, a lot of those have like a removable, really thick felt liner. And the point is, if you get some waterproof boots, folks, those are spectacular because they're going to allow you to go out and do leisurely strolls in the rain, in the snow, in the whatever. Just, you know, have the right socks and all that stuff. And it's very, very good. So, yeah, so there's that. And of course, this video is largely about how space weather arrived exactly as we forecasted. So that's always nice. It's always nice to see the arrival of solar storms exactly when we expected them. So there's that. Yeah, so it's been exciting times for space weather. And we're always excited to have viewers just like you viewing the videos. Because, look, we're no better or worse at forecasting space weather events than NOAA, NASA, ESA, University of Reading, etc. So I'm not going to cook today or anything like that. Of course, the bicycling has been sort of the amount of miles have been significantly lowered. There's all kinds of black ice and snow every place right now, so it is a bad time to ride a bike unless you got carbide studded tires. I mean, you can make your own steel studded tires, and you know they work pretty good on ice, but they work pretty bad on everything else. So maybe don't do it. I don't know. So let's talk about what we usually talk about: space weather and Earth weather. As now I'm in the real Smasho studio. And welcome to the Smash News Network, least busted name in news. Ah, yes. Oh, yes. Space weather. It's fun. It's fun. It's not scary. It's not going to kill you. Space weather. It's fun. It's not scary, and it's not going to kill you. If you're waiting for the apocalypse, keep waiting, because extraordinary claims require extraordinary evidence, folks. All right, so we're going to show you some data. There's our test pattern. That's actually my desktop, folks. So we're gonna bring up some data here. Let me just refresh my tabs. We'll talk about all kinds of things. Probably not cosmology, though, because we have had plenty of space weather. And of course, if you're new to the channel, you may not realize that I started covering space weather because of cosmology. It was a subject I considered majoring in back in the mid-1990s, but I noticed some issues with heliophysics. I'll just say that. I noticed issues. So I'm going to rock this to today's data only. And we got some action here on both the east and the west side of the sun. So the likely place to see large solar flares, folks, is over here. That is definitely a flare producing possibility on the limb there. That also increases the likelihood of solar energetic particle events, which you can follow yourself in near real time by looking at the GOES proton flux. So we also do have a massive prominence over here, this huge prominentiary coronal filament. And that is an interesting one. It's definitely some eye candy. So let's take a look at that nice and close up. And here's what it's been up to today. We'll start at 8 p.m. Universal Time yesterday and let that play through. Because it's quite a large filament. I mean, that is a few 100,000 kilometers in length. So very, very nice visuals there from the GOES 19 SUVI. And like I said, the likelihood of large solar flares, we don't really have a high likelihood of large flares. But if we do have large flares, they're going to happen over here. And we did have some significant events there. It looks like there's at least an M-class event. If you're adept at looking at this, you will be able to sort of guess the magnitude of a flare just by looking at it. That is probably an M-class, a low-level M-class event, maybe even a mid-level M-class event, taking place there around 2200 Universal Time. Bring that back just a little bit and let that play. So there's one flare. There are some likely CMEs there, definitely some big prominences associated with that as well. And let's move on to some stats. No need to comment on cosmic ray flux today. It's still at a 20-year low. It's not going anyplace anytime soon. And by the way, for everybody who thinks that Earth's magnetic poles are in an excursion, this is not evidence that we're in an excursion, okay? Because during a polar excursion, you're going to see a big increase in cosmic ray flux because Earth's magnetic field protects Earth from cosmic rays as well as from solar radiation, because there are some striking similarities to cosmic ray flux and the solar wind in that they're made from the same components. They're mostly hydrogen nuclei, so about 90+% hydrogen nuclei, highly charged particles. They really want an electron, and they're going to take one from wherever they come in contact with one. And so anyway, the point is, if we were having a real polar excursion, one that would be an actual blip on the geologic time frame, the geologic radar, there is no blip on the geologic radar. The current polar excursion is not anything resembling a polar excursion. So yeah, the field is weaker than it was in 1859, but our measurements, our direct measurements of the field, don't go back very far, folks. Were we even measuring it in 1859? I don't know. Let us know in the comments. But the point is, if you understand the physics of it, cosmic ray flux would be at an all-time high, not a 20-year low. So polar excursion is debunked by factual data. I guess I did comment on cosmic rays. Here's our only known cosmic ray point source, and it's X-ray production. Keep in mind that's radiation, electromagnetic radiation, not particles. This is particles. This is radiation. And as you can see, for the past 4 years, Cygnus X3, a high mass X-ray binary, has jumped out of its historic range. not by a whole lot, but especially larger outbursts. So does that portend a future of higher cosmic ray flux? Let us know in the comments what you think. And perhaps we'll put some commentary on your commentary. Where's my other browser? There it is. I just want to bring up the chat because if any of you actually take the time to leave a comment, I would prefer to be able to address it in text form and see it on my screen instead of on, on this screen. All right, so let's bring up the, come on then. We'll bring up the Huxt forecast here. And whoops. For some reason, now the browser doesn't like the format. Okay. If you say so. So who knows? Perhaps a browser there has dipped into defunct territory. I don't know. But I'm going to open it up in a different browser because what? Anyway, while I do that, sunspot number has continued to decline here. Sunspot number now down to 118 sunspots or so. And the radio flux coming down as well to about 168, 169 solar flux units there, as reported by Solon.info. All right, there we go. All right, so I'm just going to bring up this forecast in another browser, since this one functions. And we won't tell you what browser we're using there, folks. We don't need to call out browser makers, as they all have their own pros and cons, right? Hopefully the browser you're using is not designed by cons. All right, so there's the latest animation, and as you can see, oh, yeah. So University of Reading was on it, just like we were. They forecasted yesterday's CME impact. So did we. There's still at least one more on the way, but not too bad there, University Reading. We'll show you the coronagraph, but it doesn't look like there's anything new headed in Earth's direction. So let's break out the GOES 19 coronagraph. And do we have missing data there? It's okay if we do, no big deal. It looks like there is plenty of missing data on the GOES 19. So let's go to ISWA, the Integrated Space Weather Analysis Center. And we'll take a look at Stereo A's coronagraph. I say it's unlikely for additional Earth-directed CMEs. And we do have limited data from Stereo A as well. As you can see there, big jumps in the data. Unfortunately, not very helpful. Okay, so today's data is pretty good, though. At least we have hourly data there. So no new coronal mass ejections there of note. NOAA's forecast does not include any additional CME impacts. It is calm in the realm of space weather. We still do have quite a strong field here, as evidenced by the observations at Lagrangian point 1. So that is where the ACE is located as it orbits that gravitational equilibrium point about 1 million miles from Earth. So remember, folks, the solar wind is measured well outside Earth's magnetosphere, which extends to about 12 Earth diameters. And what we're seeing here is very strong fields, a fairly nominal solar wind, but strong fields. So there's a big push right now happening because of this top pane. So this top pane right here, the BTBZ, 16 nanotesla for the total field, with a BZ of positive 15. That's the vertical component. Think of a Cartesian coordinate system. The BZ, which is the red line, is the vertical component of the magnetic field. That's the interplanetary magnetic field measured at Lagrangian point 1 by the ACE spacecraft. So solar wind density, 6.5 protons per cubic centimeter. Solar wind velocity, 426 kilometers a second. No spikes in the proton flux. Don't be surprised to see solar energetic particle events that would significantly increase the radiation exposure for people on solar flights, as well as for astronauts. If we do see an SEP, a solar energetic particle event, this is what I talked about earlier. You can follow the GOES proton flux in near real time at SWPC, the Space Weather Prediction Center. Looks like we've only had C-class intensification so far this day, but we are also seeing a flare happening right now. So let's go back to the GOES 19. I'm going to separate that tab. Are there any options on this now? Nope, no options. All right, no problem. Let's see if we can see where that flare is coming from, folks. No idea. All right. So this is actually old data here. I'm going to press refresh, but I don't think it's going to help. That's why we call it near real-time data. And doggone, is that taking a long time to load? Try again. Maybe a lot of people looking at the Space Weather Prediction Center right now. I don't know. I can assure you this, our internet connection is blazingly fast, so there we are. Let's see. We may have the up-to-date data there. Give that a minute. It may be well worth it. I suspect it's going to be in the southwest. Probably going to be down here, folks. That is certainly the most likely place to see flaring and indeed large flares. So moving right along here. Once again, there's the GOES proton flux for the past, the GOES X-ray flux for the past 3 days. That is X-rays. This is showing solar flares, folks. And remember, don't get them conflated. These are particles, very high speed particles. They're at greater than or equal to 10 mega electron volts. That's 10 million electron volts, 50 million electron volts, 100 million electron volts, and 500 million electron volts. Those are some energetic particles indeed when they show up. This orange line here, those are the highest energy measured by the GOES proton flux. Anyway, that's what's going on. Space weather is pretty calm. Let's take a look at our magnetic sectors. We're going to show just today. Here's what's going on in the heliosphere. Earth is still solidly in a South Pole-oriented magnetic sector. I see your comments coming in there, viewers. I will get to those in just a minute, but first, the line of sight coronal hole plot. Because the coronal holes are in charge of the heliosphere's magnetism, those open field lines extend way out into space. All right, so here's today's coronal hole line of sight plot. And that is what's going on. South Pole-oriented coronal holes shown well. Bear with me a minute here. I want to put the chat onto my computer screen because it's inconvenient otherwise. And thanks for leaving comments, those of you who have. Ruchel Montenegro says, what? Well, that doesn't warrant a response, does it? Sid FX1000 says, improve your propaganda for more viewers. There is no propaganda on this channel. We cite facts and we empower people to understand how to forecast their weather, space weather, and take charge of their fitness. So that's what the channel does. There's nothing resembling propaganda. And just to comment on that briefly, propaganda is a very different term in Europe than it is in the US. So when Americans say the word propaganda, we mean something that's not true. It's not just we're trying to convince somebody of something. Propaganda is considered deceptive in the US. I didn't know this until Eugene the philosopher enlightened me on this one. So anyway, there is no propaganda on the channel, but thanks for the advice. We're going to show you the magnetic fields of the photosphere next. And how about El Teide, Spain? On the Isle of Tenerife, on the massive volcano of El Teide. Here's today's data only. And let's zoom way in and check the magnetic complexity of these sunspots. So not very magnetically complex. It looks like they have degraded since yesterday. We'll stick with El Teide as their imagery looks pretty clear. There's the red light view. That's 677 nanometers. There is still a little bit of complexity in those sunspots. They're certainly beta gamma class. I just don't think they're beta gamma delta class. So that's what's up with those sunspots. Again, there is still a significant chance of an X-class solar flare there, especially in that southwestern limb, but not nearly as high as if those were beta gamma delta sunspots, which again, they are not. Next to hydrogen alpha imagery, which its absorption features are great at showing solar filaments, of which there are quite a few on the Earth's side of the solar disk, not nearly as many as a few days ago. Let's just show today's, as we've been showing only December 11th. So this does show all the bumpiness of the corona. And of course, you can see this absolutely massive prominence down here, very well represented on that imagery. You're looking at the hydrogen right there, folks. That is the hydrogen. Where you see bright, pushing white, that's a lot of hydrogen. And where you see dark spots, like these areas up here, see these areas here, these are filaments. Those are absorption features. They're blocking the hydrogen from getting there because they're more molecularly complex. There are lots of chemicals in there that aren't hydrogen. The sun's corona is quite the chemical soup indeed. It is far from homogeneous. Electron flux here, it looks like it is subsiding the electron storm. So, yeah, that looks like a real subsiding of the electron storm. So you're going to see a little bit better GPS performance in the coming days. That's a plus for all you GPS users. And thanks for leaving a comment, Stratotanker8373. We're going to skip the ionosphere today because my voice is more valuable. We will show the water vapor map for the Western world. That's what's going on, and the atmospheric river is now making its way into Texas. Texas and Oklahoma and Kansas. And let's don't forget the hot air capital of the world, Colorado, Wyoming, and Montana, and Washington. And let's don't forget Oregon. Have a lot of moisture over their heads. There's an even better view of that. Quick reminder, when the water vapor map, when the Doppler radar doesn't show you what you want to see, if you're like, how is that rain magically forming right there? Please look at this map. If you understand atmospheric physics, you will be able to forecast your own weather. The water vapor map is crucial. Know it. Use it. You certainly can forecast your own weather, and we hope you do. So here is the radar map. And we've got lake effect snow across the Northeast. As the Great Lakes accelerate the winds, you can really see evidence of that here. Look at these bands of precipitation here coming off of the lakes. Yeah, the lakes, they accelerate the winds because the heavy air gets pushed down to the ground. And then the next thing you know, it's only got one direction to go. So yeah, lake effect snow, that is a big cause of it. The acceleration of winds over bodies of water. If you live on the east coast of the Great Lakes, you'll probably agree. Next, we'll show this beautiful satellite imagery from windy.com, who has a great mobile app, by the way. There's the animation for where we're located, which is in Lehigh Valley, Pennsylvania, by the way. Cycling Mecca, world-class cycling Mecca. Give that a minute to load. It's well worth it. We may have to stop using this browser, folks. It's trying to get me to upgrade. I ain't upgrading jack. There we go. So there's the animation. You can see the sunrise in there over the beautiful Atlantic Ocean. And over less beautiful New Jersey. No offense to our Jersey viewers. We don't dislike the people of New Jersey. We dislike the roads and the laws and certain officials, certainly. So anyway, that's what's going on. Space weather's pretty calm. And Earth weather is interesting. Got any news stories you'd like me to comment on? I'm more than happy to do so. But I guess what I'll say is this. The NASDAQ is a giant bubble of junk stocks. Junk stocks. This AI bubble, it's the biggest bubble that's ever existed. So, yeah, there's that. The stocks are more overvalued than they were in 1999. So remember pets.com? Remember that? Yeah, now it's AItrashware.com. So, yeah. Artists don't like it. Businesses who use social media hate it. Content creators hate it. Everybody hates it except people that think it's going to create some kind of utopia, or people who claim it's going to create some kind of utopia in order to get other gullible folks to invest. I mean, when I graduated high school and started college, I was a computer information science with math background major. I was writing code before kindergarten, and The companies who are the pioneers in AI, they should learn to code. Uh, if you're if you're concerned that AI is going to like take over the world and kill us all, uh, you may want to implore the pioneers in AI to create a functional smartphone app first. Let's let's start with one bug-free smartphone app, and then maybe we can talk about world and galactic and universal conquest. How about that? Does that sound, does that sound a little bit more reasonable than, oh no, it's gonna be the robot apocalypse. I'm so spooked. It's pretty pathetic, folks. Pretty pathetic. All right, we're going to close out the video with some views from nullschool.net for all you earthlings out there. Here is the jet stream. That's the 250 hectopascal winds. And you can see cold air coming down here over the Great Lakes, all the way down to places like Georgia and so on. The jet stream will give you an idea of what the weather is going to do next. If this was coming up like this, you'd get warm weather in the eastern U.S., for example. So right now, it's real hot in San Diego. Look at the way the jet stream is pulling air out of Baja California and the Gulf of California and out of Mexico. That is the formula for warm weather. Here are the surface winds, as you get to see the insane winds going across the Great Lakes. There you can see that acceleration of winds that I talked about earlier. Yeah, the land, it has obstacles. It slows the wind down. Water speeds the wind up. This might help you forecast if you have any clue how to forecast. Now, the weather is largely in control of this. This low up here, this is not a super strong low, but it is a very large low. You can see how huge that is. It doesn't get real strong until you go up here south of Iceland. Down there, that is vicious. 936 hectopascals. Dude, that is legit. That's like hurricane force low pressure. You see that? That is not a place to be on a Viking open top boat. Now is not the day to row across the North Sea. Okay? Let's look at the wave heights. If you don't believe me, watch this. Yo. 43-foot waves. 43-foot waves. Look, there it is. Read them and weep. 43.2 foot right there. That is an absolute tower of water. That makes me frightened just thinking about it. That is a hell of a place to be. Dag. We'll also take a quick look at particulate matter. Got Saharan dust? Yeah, there's some Saharan dust there blowing right across the equatorial Atlantic. It's not very dense. It's fertilizing the shores of South America. Shout out to our viewers from South America, like Bruce Minas. Hopefully everything's going well for you there, bud. Hopefully you didn't get any horrifying floods. We don't want our buds to be screwed by horrifying floods. So here's a pressure map for the whole Western world. And here's a temperature map while we're at it. You can see that cold air flooding into the U.S. as we stated. Anyway, it's time to close out this stream. Thanks for tuning in, folks. Everybody who has, don't forget to press the share button, leave a comment, whether you viewed in syndication or live. Thanks to each and every one of you. Congratulations on realizing the channel exists. Until next time, I've been your host, Dan, a.k.a. Smash-O-Mash, signing off. And may that solar wind and that lake effects wind be at your back.